All right, hi everybody. Finally, we come to another video on ontological mathematics and the theory of everything. Now, this video is part 7, but really, what about science and physics? Dualism resolved. You may notice that part 6 has been skipped because it ended up just being a rant video about science. It's not really that substantial. So we're going to skip it and go straight to 7 and show you some really cool mathematics. So remember, ontological mathematics and the theory of everything is based upon the philosophical idealist treatise by Mike Hockney. So part 7, what about science and physics? How does this relate to science and physics? Because ultimately that's what we want it to do we not? So we have built-in unification via the principle of sufficient reason as Euler's formula, as we've discussed in previous videos. So this I will demonstrate in future videos, but let it just be said that relativity may be derived with Euler's formula and its interpretation of spatial and temporal components in the circling. That's a really, really fun thing to see. That's going to be a fun video to do. Euler's formula is also the basis of the Fourier transform, which is the basis of quantum mechanics and also of thermodynamics. So you see a lot of things are being tied in together. A lot of fields of physics are being automatically tied in together here, isn't it? So basis for unification, all of laws of physics, is now built into what we've set up. And what have we set up? Well, our setup is nothing more than determining what must fundamentally exist. And having determined what must fundamentally exist, we find that we have automatic unification in the major fields of physics, right? Relativity theory, Fourier transform, which is based thermodynamics and quantum mechanics. And so it's quite fantastic. Really, we should be able to get to a Fourier theory of gravity really easily from this. So the Heisenberg uncertainty principle, this is a physics concept, becomes a natural and expected result of the mathematical properties of the Fourier transform. It's a Nyquist, what's called a Nyquist frequency. I'll show that later. And quantum mechanics returns to determinism and rationality and total explicability rather than this Copenhagen interpretation and this utter confusion that the scientific establishment suffers from. And also finally, of course, with the circling in Euler's formula, we describe fundamentally what light actually is. Have you ever considered that we don't really know what light actually is? Oh yeah, sure, we call it an electric wave and a magnetic wave, but where do those originate from, and why do those exist in the way that they do? So now we have that explanation via the circling. That's what a circling is. A circling is a photon. That's what it actually is. And we now can define what energy is. And science has never done this. Science has never ever been able to define energy. And it's never even really bothered to make an attempt or make any statement about what energy is. So we now can define energy with ontological mathematics and with the circling, with Euler's formula. And starting from there, we have the basis for the unification of relativity with the Fourier transform, with quantum mechanics and thermodynamics and all this wonderful stuff. So the ontological Fourier transform. So this site, the FourierTransform.com, states, one of the fundamental secrets of the universe, all waveforms, no matter what you scribble or observe in the universe, are actually just the sum of simple sinusoids of different frequencies. That is a wonderful statement, indeed. So how does that work? What's the math for that? Before we get to that, central to the Fourier transform is the equation of the circling and the sum over all possible circlings. And we discussed that previously, didn't we? As the monad. What is the monad? The monad is a sum. A single individual monad is the sum over all possible circlings. All obviously following the equation of the circling. That's fundamental. That's what the Fourier transform is all about. So the Fourier transform, therefore, becomes totally identified with the principle of sufficient reason, because the principle of sufficient reason was what led us to this circling in the first place, and Euler's formula in the first place. And now the Fourier transform is fundamentally about the equation of the circling and the sum over all possible circlings. I mean, that's just fantastic. Do you see what's all being unified here? Yes, of course, I know you'd like to have a demonstration. So would I. We can only demonstrate so much so far. Therefore, identity with the principle of sufficient reason, identity with a base construct of existence. The Fourier transform is just as fundamental as everything. It just naturally comes out of it all. Okay, so dualism resolved by mathematical monism. Well, what is dualism? Dualism is the problem of mind versus matter. If all that exists is a mental construct, then how does it create this appearance of matter and of extension and of worlds and planets and objects in space-time? So how does it do that? It does that with the Fourier transform. So for example, with the what's called the forward Fourier transform, the question basically is, given a space-time object that you want, which you just call f of x, that would be your space-time object, the function of the space-time object, what frequencies do you need from the singularity, from the monad, from the singularity, to create that object? This is the equation for it. These are the frequencies you need, and it's equal to that space-time object multiplied into the circlings in the singularity, and you integrate over all possible frequencies. That's how you get it. So these frequencies will create this space-time object. Now, the inverse Fourier transform, given a subset of frequencies from the singularity, should have perhaps started here. This is a bit more clear because what we want to create is a space-time object, right? So given a subset of frequencies, f of sigma, from the singularity, what space-time object will they create? So this is the space-time object, f of x, and that's equal to the integral over all possible frequencies times a function of frequencies and all possible frequencies, right? So you integrate over all possible frequencies, but you select a few out. That's what f of sigma is. You take a few frequencies that you want and you take them out of the singularity with this Fourier transform and you get this space-time object. Now think of this in terms of, say, evolution at the beginning of life. What would monads have been doing with life? They would have been experimenting with this. This is how they would experiment. They would experiment with picking out frequencies from the singularity and seeing what space-time objects they create. Now, originally, a long time ago, that would have been very, very, very simple sort of objects, sort of life forms that would have been created. Now, f of x is as complex as a human body, for example. So a human body is a very, very complex space-time structure, right? And so that needs a very complex set of frequencies taken out of the singularity and transformed into space-time to make our bodies, right? So this has become very, very complex over billions of years of evolution. At the beginning, it would have been very simple. Only a few frequencies, relatively speaking, would have been sort of transformed through the Fourier transform into space-time to create, say, a single-celled organism. Still, obviously, incredibly complex. You know, science still can't really explain how you could have such an incredibly complex thing like a single-cell structure. Well, there's mind governing that process. There's mind doing that behind the scenes. There's mind running that to build life forms and to eventually build us to become conscious. So fundamental physics questions answered. So what is energy? So again, energy is a circling, which is a basis thought, which is a frequency of motion. It's a mathematical object defined with numbers, which is merely to say with reason. It's explicable. It's not arbitrarily inexplicable, as science defines energy. It's just some arbitrary inexplicable thing that works with math. We don't know why. Well, with the principle of sufficient reason, as I've demonstrated in these previous videos, we can totally explain what energy is and why it exists and why it has the properties that it does and that it's totally logical and should exist. So it's abstract by definition, but we mean by that ontologically abstract. It's a mental thing that truly fundamentally actually exists. It is what exists and is mental in the philosophical idealist sense. And so, for example, what is a fundamental particle? So, for example, if you ask science, what is a fundamental particle? They can't really say what it is. It just has mathematical properties. But we can't really say in science what a fundamental particle is actually made of. Well, for example, it is a single circling of a given frequency and energy transformed into space-time as delta function. So the details of this is that the inverse Fourier transform of a single frequency from the singularity creates a point in space-time, creates a delta function, what's called a delta function or a point in space-time. So a single frequency, so a fundamental particle, in other words, is a single frequency. It's a single frequency from the singularity domain, from the singularity, transformed into space-time, and the Fourier transform of a single frequency creates a point. And in physics, in science, fundamental particles are considered to be points. Well, nowadays they're considered to be strings. That's a detail we could maybe get into some other time. But the basic concept here is that a single frequency from the singularity, when transformed through the Fourier transform, creates a point in space-time. And that's, of course, how we think of fundamental particles in space-time. Now, for example, this is from a third-year astrophysics text. So in about third year, in a course in physics, in the core STEM field like astrophysics or physics, in and around third year, you'll have been getting used to the mathematics and the calculus of the Fourier transform. And so this is from a third-year astrophysics textbook. And it shows you a few examples of space-time functions and their counterpart in the frequency domain, in the singularity. What frequency spectrum is required to create them? For example, like that equation we had before, what frequencies do you need from the singularity to create an object in space-time? Now, this first example here shows a delta function in space-time, which is a singularity, a single point. And this is created by all possible frequencies summed together. See, it's just a constant. That means all possible frequencies. This is sigma, that means frequency. Okay, so all possible frequencies summed together through the Fourier transform creates a singularity. Now, isn't that kind of neat? Because that's what the singularity is. The singularity is all possible frequencies that could possibly exist across all possible monads. And what is it? It's a singularity. So that's kind of a neat sort of connection there, isn't it? I mean, it's automatic and obvious, isn't it? A cosine function creates an even pair, a pair of delta functions. Okay, so it'd be like a pair of point particles, so to speak. A sine wave, which is antisymmetric, about 0, creates an odd pair of delta functions, so one negative, one positive, right? So what kind of properties does this mean? I mean, if these are fundamental particles, if fundamental particles are basic singular frequencies, then, you know, once we develop ontological mathematics and ontological physics, we'll see that, oh, well, you know, a single cosine of a given frequency corresponds to, say, the up quark, you know, and an odd pair would be something else. Maybe that's like an electron or something else like that, you know? So that's what we will eventually develop. You know, a particle physics based on ontological mathematics, based on understanding what they actually are, what these objects in the space-time actually fundamentally are in terms of their basis frequencies, in terms of their circlings as they exist in the singularity. So, for example, if you want a box is created from what's called a sinc function in the singularity. Sinc function is just sine x over x. So this distribution of frequencies from the singularity creates a box. And then sinc squared, so this distribution of frequencies from the singularity creates a triangle. So that's how you create a triangle in space-time. Pretty neat, hey? Obviously it gets more complicated because, you know, what minds are actually doing is creating DNA and replicating cells and organisms and things like that. So it gets obviously much more complex. But we love these sort of examples because they're nice analytic functions which produce nice analytic solutions that you can actually write down. Otherwise, generally you can't, and they become, you know, sort of numerical approximations. Okay, so anyway, very neat example of how space-time objects transform directly to singularity domain frequency distributions. So distributions of frequency picked out of the singularity and transformed in, like with a selector function, transformed into space-time, create objects in space-time. So wave-particle duality explained, ontological Fourier mathematics makes it so simple. What manifests as the appearance of a particle in the space-time domain is actually composed simply of an underlying basis frequency from the frequency domain, from the singularity. De Broglie's pilot wave theory is probably what's the best way to handle this in the space-time domain. All of Copenhagen and its, you know, terrible interpretations and all of its contradictions will be discarded eventually, and we will fix this all up. Yeah, you can think of space-time as being where we experience the wavefront. So space-time actually all exists in the singularity, and the singularity is undergoing, you know, all of these frequencies. Now, space-time, as we experience it, is a selection of the frequencies from the singularity, and we are sort of experiencing that wavefront as it passes through the current moment, right? So we experience the infinitesimal current slice of the wavefront, right? Yeah, so space-time is moving through the wavefront in the singularity, right? And yes, this can be used to explain the constancy of the speed of light and come up with a totally different interpretation of relativity, which still totally explains everything and performs all the results of relativity, but now actually with an absolute framework, the absolute framework being the speed of light itself in the singularity. Heisenberg uncertainty as ontological calculus, so you have the forward and inverse Fourier transforms as we've seen them. So sigma, which typically represents energy or time, and space, and x, which is space or momentum, in the equations for quantum mechanics, become intimately related. They're called Fourier pairs. So the Planck scale and the Planck constant become the ontological limit of the calculus in the space-time domain. So dx and d sigma, these terms right here, they're the limit of the calculus, so to speak, yeah? So then you have a Nyquist or cutoff frequency, that becomes the Planck scale, and typically that's the equation for it. So we have a lot of the basis for quantum mechanics, for basic quantum mechanics, built right in to the circling and to the Fourier transform, which is an automatic part of the circling and all that. So we are ready to go with a totally new theory of physics here, and really the fundamental theory of physics, because now we're dealing with base reality as it actually exists. We're not simply creating models to model what happens. Now we actually are going to treat the math as it actually fundamentally exists in and of itself, as reality and existence itself actually is, right? Based on the circling. So suggested reading, three originators of ontological mathematics and Illuminism. These were the three original guys, Mike Hockney, Michael Faust, and Adam Weishaupt. You look those fellows up, you'll find other more recent authors, but these are the people who've been doing it for the past almost 15 years or so, I suppose. Discussion of philosophy, mathematics, science, and religion is perfect. No greater perfection of reason to be found anywhere else in the world from any time. It's all really quite good. All right, and so next time I was thinking of doing this, part 8, what and who is God, and why did he create the universe? Now, that's obviously provocative because, we're not supposed to think of the Abrahamic God or think of creation in those sort of terms, right? And certainly I'm not using it in that sort of term. So what could I possibly mean by that? That will be left for the next episode. Okay, hope you enjoyed that quick one. Cheers. Bye-bye.